Hello everyone, welcome to Aribhat Ashram. Today we will be taking the question number 2C of complex analysis. Before we do so, let us see on the similar lines we have asked some of the questions. And this was the question which was given as a top 40 question for contour integration and this is your using contour integration to find 0 to 2 pi d theta by 2 plus cos theta. Now here answer verification technique is very important. So what we can do is that we know the general formula for 0 to 2 pi d theta upon a plus b cos theta, that is equal to 2 pi under root a square minus b squared. So here a is 2, b is 1. So your answer is 2 pi under root 4 minus 1, that is 2 pi under root 3. So we can always verify our answer, and we have done this kind of question in our analysis part as well when we were doing the analysis of complex variable. So these questions are very important, and if you know the beforehand what is the answer, then you can always reach to that. So on the similar pattern we have given in our test series, this using residue theorem, we have to evaluate this integral from 0 to 2 pi d theta upon 3 minus 2 cos theta plus sine theta, as has been already reiterated in the analysis part, that when we integrate along a unit circle d theta by alpha plus beta cos theta plus gamma sine theta is equal to 2 pi under root alpha square minus beta square minus gamma squared. So if you here alpha is 3, beta is 2 minus 2, and gamma is 1. So your answer is 2 pi under root 9 minus 4 minus 1, that is 2 pi under root 9 minus 5, that is 2 pi under root uh, 4, that is 2 pi by 2, that is your pi is the answer that you get. So in this question we have given the test, and many of you got wrong while finding the roots of this equation. So if you know the answer beforehand, that is the pi as in this case, so you can reach to your answer. So that was the purpose of using some of the well-known results if we know, and if we keep that in mind. And I have also highlighted the question asked in 2014 as regards when the power of 2 is there, so that you can check in our video. We'll pin that video as well if you want to do the further analysis of that. Now coming back to your question, that is the question which has been asked in your 2020 examination. This is a question. Now beforehand you know the answer to this question. So this is asked for 20 marks, and you are supposed to do it by contour integration. And again, it's on along a unit circle, that is 0 to 2 pi d theta by 3 plus 2 sine theta. So we know these results: a plus b cos theta or sine theta, whatever the trigonometric function. So this is your alpha a square minus b square. Okay, and a is greater than b. So you know the answer is 2 pi under root 9 minus 4. So you get your answer right. So you know the answer beforehand, you can easily solve this question. Now I'm coming to solve this question. Now that's the standard thing that we do. We put z is equal to e to the power I theta. Okay, and mod z is what? It's a unit circle. That's what it is. And we know the trigonometric. So sine theta can be written as e to the power I theta minus e to the power I theta upon 2i. So sine theta I can write in terms of this as z minus 1 by z upon 2i. So this is nothing but z square minus 1 by 2ij. Now how we can put this value? So along this contour, this is your we'll put all of those values. So dz is your I e I theta d theta. So d theta can be written as dz upon I z. So I can write d theta as dz upon I z, and here our values as 3 plus 2. So 3 plus 2. Here we can write sine theta value is your z square minus 1 by 2ij. along this contour, that is a unit circle, we are evaluating it. So this gives us dz 2 get cancelled. So 3iz plus z square minus 1 into, and this iz goes at the top, and this get cancelled. Okay, so what we are supposed to find, we can see this is here. So if we factorize it, so if alpha beta are roots, so we can write this as minus 3i plus minus 9i square minus plus 4 upon 2i. So this is 3i plus minus 5 upon 2. So alpha beta that we get is here minus 3i plus minus root 5i by 2. So first we get this as one of the roots alpha, and now it's abundantly clear that alpha lies within the unit circle. If we draw the unit circle, mod z is equal to 1. So alpha lies within unit circle, mod z is equal to 1. And we choose alpha as minus 3. Okay. And beta as, so this is root 5. This is something 2 point. So this is your minus. So this lies within unit circle, whereas this goes outside the unit circle. Okay, this is 2 minus 2 and minus 3 minus 5. So 2.5. So it is by 2. So it's beta lies outside unit circle. Okay. So if we want to find the residue at z is equal to alpha, we can write limit z tends to alpha, z minus alpha into fz. This is nothing but z tends to alpha, and this is z. We can write this as, we have factored this as z minus alpha into z minus beta. This get cancelled. Okay, so we got the residue as 1 by alpha minus beta. So alpha and beta is already known to us, so we will subtract that. This is minus 3 plus root 5 upon 2 minus plus, and so this is nothing but your root 5i. So using residue theorem, we can write this integral as how much? 2 pi I into residue. What is the residue? I get cancelled. So as already envisioned, that 2 pi by root 5 should be our answer. Now if you make any calculation mistake or any fundamental mistake like this, like if you put numerator and denominator upside down, or if you forget this I, then these are the silly mistakes that may happen, as has been seen in the test. That what I'm trying to say, if this is the case, some of the students will write this as, due to the silly mistake, they will write this as root 5, and they will write it this way, or other part they may miss here I, so they will write this as 2 pi minus 5. Now if you do such errors, then you will lose your marks heavily. So that is was the point, was that we know beforehand our answer, and whatever questions that has been already dealt with, if suppose this was a question that was asked in 2014. So this was the square part, it can be signed. So we know this is 2 pi a upon a square minus b squared 3 root 2. So you can always do it. So whatever the question is, we are supposed to do along the contour using contour integration, any sine or cos. So we know what are those questions. So you can refer to the Aryabhatta sheets on contour integration, and you can be rest assured that you will be able to do any question that is asked in whether IS examination or IFS examination. So this is the comprehensive way to do any of the questions, and any half-hearted preparation or half-baked materials that you study from the market, that might cost you, because at the end of the day, until unless you are very supreme in your optional subject, and there is no scope for any error, and you cannot afford to make errors because it will pull down your marks heavily. So this was a simple question which was asked for 20 marks. Answer, we know it from beforehand. This is the thing, and this is how what we at Albert Ashram try to make simple things even more simpler, and there should be no chance of error. And where in the test also we just try to find out where students are making mistakes, and then we can give you a very corrective feedback upon which you can work. And this is how and there is a pattern and symmetry in mathematics, and if you just try to analyze it for yourself, you will be in a very cushy and commanding position to take this subject to the next level. And that's what is the message that I want to give through this question. Any value addition as regard this contour integration, this was asked for 20 marks. So if you draw the diagrams, if you show the unit circle, if you write each and every steps, because this question was of 20 marks, so you can write elaborate steps. And this year they have asked very simple questions from complex analysis. They do it invariably every year, but they can give you some questions which keep you off guard. So the best approach is that you prepare last 20 to 25 years question which are within the domain of UPSC syllabus of today's. Okay, things which are not in the syllabus which were earlier, you need not worry about that. And once you know where the questions are being asked from, and you solve them, and if you have certain basic understanding, you will be able to do any questions. And question may appear easy, tough, lengthy, that is not within our domain. What is within our domain is that we can put our hard work, and consistently we do certain problems, and flow is very important in mathematics. So if you are on the go, and if you're constantly solving those questions, then you will be always getting good marks. So if you really like this idea of solving and trying to put perspective on each and every question, then you can write in the comment section, and you can tell us as to which areas which you find difficulty with. We will try to come up with resolved way of doing certain things in a very nuanced manner. So thank you for watching.